start the video. Let's call it P5. And it is going to be, well, no, it's not in a way. P5 through P7 quiz, meaning we won't revert backwards. But did you notice on your quiz you did not have, I hate when that, any of those? An absolute value inequality. You only had an absolute value equation. Hint, hint, hint. So this wasn't on the last quiz. I have no idea. All right, so here we go. But let's go back to this one. Simple, Simon. The other math teachers are actually saying ignore this as an inequality, make it an equation, and do a number line test. Not on a simple linear situation. But I am going to show this because on the quiz, we made this mistake a lot. So I decided to get the X's on this side on purpose because this was the mistake that was done quite a bit. And I guess the number line test solves this scenario. So I think I see why the other teachers are doing this. But you still should know when you divide by a negative what happens with the inequality. It flips. You should know that generally as a math concept. So the other teachers are just making that an equal sign, getting x equals 3 halves, put 3 halves on a number line and then check. And then what you find out is the number's smaller than 3 halves work, which is good. I'm not ripping on it, but I also think you should know the idea that the inequality flips when you divide by a negative. That's a math thing. All right, so if you wanted to ignore that, make it an equal sign, x equals 3 halves, put 3 halves on a number line, and then when you check, these numbers work and these don't. So it is less than. All right. That's also good. So I'm not ripping on what they do, but I think we gotta know that idea as well. So the real answer is negative infinity to 3 halves with a bracket. So it's good to kind of review that. And now it's really good to review this one. What's the matter? Me? No? Okay, no, we're good. I just heard someone say wait, and I just wanted to make sure everything was good. I know you have to take your own notes, so I do have to pause. When I give you a note sheet, I'm flying then. If you have the examples typed out, we're moving. By the way, I wear this shirt because on Wednesdays I wear a math shirt. I have a whole bunch of math shirts. But what is this symbol for? 3, 2, 1, go. But without math, there'd be no NASA. As a fatter fact, anyone ever hear of Voyager? The Voyagers 1 and 2? You guys make me sad. You guys should know about how many people know about Voyager? A little bit. It's still going, actually, and it's still sending signals, but it was sent out in the 70s. But to get Voyager to work, an actual mathematician, not an astrophysicist, a mathematician in a college, figured out how we could get Voyager to the other planets by using the slingshot method, using the gravity of planets to get it. And he actually figured out that we got to do this right now. This is in the 1970s. The next time the planets will be aligned like this is like in another 175 years. Who's coming in? Why is that still locked? Is this another student or is this a teacher? Oh no. You have to come over here. I'm tethered to this and I'm taping right now. Sorry, YouTube. All right. Is there a Carl and a Caden in here? All right, come on up. I know my students sort of, but all right. What does that say, by the way? Is it later? Oh, you have to go now. Darn. Okay, yeah, go ahead and go now. Hopefully it's not big. All right, so back to this. Subtract one, so that's why I'm wearing math shirts. Then some of them are just comedic, but I just like giving math credit, throughout the year, and then divide by 2. So you don't have to worry about that flipping an inequality if you divide by a negative, if you just ignore the inequality and do a number line test. By the way, I'm going to do this. So absolute value of x minus 7 is less than 2. I told Sammy Samuelis this. And if you can remember this, you're good to go. Yep, I called her Sammy Samuelis. I actually call her Sammy, double Sammy. Anyway, she's doing this right now as a sophomore. And I told her, hey, when you have absolute value less than or equal to a number, then you're going to have an in between as a final answer. When it's absolute value greater than or equal to a number and not a variable, then you're going to have going in opposite directions. Do you guys know what I mean? Okay, when you get your solution set. And if you can remember that, good, good. Because I actually like math efficiency. And I like that you can remember these things. If you don't like that, well, then just do this. You still kind of have to do this regardless. Ignore the inequality, make it an equal sign, do your two cases, positive 2, negative 2, solve each, x equals 9, and then x equals 7 plus negative 2, which is 5. And then you could skip this step if you're a good memorizer, or if you can remember it but just say, okay, let me just make sure. And I'll tell you what's going to happen. It's either going to be true false true or false true false in straightforward inequalities less than or greater than a number, not variables. Variables throw the whole thing out the door. You can't, there's no, you really got to do some number line checks. All right. And then what I'm going to check is 0. And when I plug in 0, I can plug it into the original. I'm fine. 0 minus 7 is negative 7. Absolute value of negative 7 is 7. 7 times 2 is 14. 14 plus 1 is 15 less than 5. True or false? False. 3, 2, 1, false. So guarantee that this is going to happen. But let's check. 6. 6 minus 7 is negative 1, but then 1. 1 times 2 is 2. 2 plus 1 is 3. 3 is less than 5. So I proved the true, and then I could check after 9, 10, and it would be false. So therefore, it is everything in between, and it's not equal to, so it is 5 comma 9, which is so weird for interval notation because it looks like a coordinate. It's not. This means all x is between 5 and 9, not including 5 and 9. All right. Remember, this wasn't on the last quiz. Remember? Okay, then this is why I had you hold your homework. Okay, just solve the inequality. Okay, solve these inequalities using a number line analysis. Okay, right answers in interval notation. Reflect using a graph. I'm not going to use a graph right now. I feel like this is out of place. We're going to solve inequalities again in a more complicated fashion in chapter 2. That's when I feel like I want to talk about the graph. I want to overload you on thinking about a graph right now. But what is the graph of an x squared, by the way? 3, 2, starts with a P. 1, 0. Parabola. And then in this parabola, if you graphed it, would go up. So I'm going to give you some stuff that I didn't give last hour. By the way, do you see this? And I'm sorry, I don't know what happened with my homework with the numbering. I think I printed a Word document when it was still in Google's, like Google Drive, and it really screws up the documents. You see the numbers on there? They're actually, it doesn't say 6 on number 1. And then some of the other ones just have colons and commas, right? Yeah. Sorry about that. That was just a copying mishap. All right. So looking at number 1 on your yesterday's homework, isn't this the same thing, but it was an equation, right? So what you should have got there is this. I'm not covering it. You can't do an MA on, wait, did I do it right? Okay. If you can't do an MA on negative 20 and negative 1, we got a problem numerically. Told you, numeracy is going to be an issue. Okay, and then you ignore the inequality and do a number line check. But what did I just tell you? Less than or equal to 0, is that more than likely going to be an in-betweener or going in opposite directions? 3, 2, 1, go. It's an in-betweener. So you can kind of hold that and say, all right, I'm expecting an in-betweener. If you can be Sammy Samuelus and remember that stuff. I don't care showing you that stuff. I don't need to make you do a number line every time if you can trust it. I'm looking for a correct final answer with a little bit of factoring work. Oh, by the way, x equals 5. I don't want to see x minus 5 equals 0. Add 5 to both sides. X equals 5. All right, we're in CAT. We should be able to figure out the zero product property really quick. And then we get negative 4 and 5. Yeah, it's put on my desk. I trust you. But I'll look at it later. Oh, righty then. And then what's the easiest number in the world to check? 0. And it is in between negative 4 and 5. 0 minus 0 minus 20 is negative 20. Is negative 20 less than 0? True or false? True. I proved it. And then what happens with negative 4? I'm going to bore you with that. When I plug in negative 4, that's 16 minus negative 4, which is plus 4. 16 plus 4 is 20. 20 minus 20, less than or equal to 0. True or false? True. That means they are part of the solution set. Same thing as 5. And then if you look at our book, which we've never looked at, they use that for their graphing. You want to put closed dots, fine, but no closed dots turn into brackets. Everyone okay? See that one? Now, I had the honor of being able to work with someone in tutoring today, one of our own, in my 6th or 7th. He just put on my desk. And I actually said to them, when you add 3 to both sides and you have to solve this, it might be just as easy to use the quadratic formula on this because that's like 2-3 steps. Because you might do a 4-step factoring on this and then have to do the 0 product. So there might be equal amount of time on that. But I refuse. I refuse. Remember this yesterday? It was you. I asked you what equals 3. What times what? What times what equals 3? One times 3 equals 3. But then they both have to be what if we have a middle term that's negative? So right off the bat, I know it's minus 1, minus 3, no matter what. This is going to save me so much time. And then 4x squared is either 4x and 1x or 2x and 2x. I like 2x and 2x right away. I can visualize. Because if I put 2x here, that makes negative 6x. And if I put 2x here. Yes, 2x's. That's another negative 2x. That's negative 8x as a middle term. This is fast. This is efficiency. This is what we need to be doing. All right? So we need to be figuring this out because it'll help us in the long run in factoring anyway, the nature of it. The nature of factoring being unfoiling. Right? And then that's fast. And why did I change this to an equal sign? Because I'm ignoring that for a second, doing the number line test. But it would have been less than 0. What can I expect? An in-betweener or going in opposite directions? 3, 2, 1, go. An in-betweener. So we need to focus every step of the way so that we understand these things and not take our time or take spots where we're going to pay attention and not. Oh, yeah. And then please be good solvers. If I said 2x minus 1 equal to 0, you'd have to add 1 and then divide by 2. 2x minus 3 said equal to 0, you'd have to add 3, then divide by 2. Do that fast. Okay, fine. You didn't pay attention and listen to what I do with Sammy Samuelis here as far as these testing is and not having to do this. You don't know that this should be an in-betweener or not. Then you plug in numbers. And then look at what I did. 0. 0, 0 plus 3. Sorry. Let's do this. It was a less than. So I want to check this one. Is it less than or less than or equal? Less than. So is 3 less than 0? True or false? False. So that means this is going to be a true and that's going to be a false. That's usually how it works in a standard inequality without extra variables on the right side. The number I'd pick here is 1. Bore you with that one. 1 squared is 1. 1 times 4 is 4. 1 times 8 is 8. 4 minus 8 is negative 4 plus 3 is negative 1, which is less than 0. That is proved to be true. And then I won't bore you anymore. 3 halves, 2. Actually, I asked last hour, what number is between a half and 3 halves? You do need to know that that's 1. All right? So 1 falls there. And then 2 would be a false. So anyway, it's this. And then parentheses. So that's what the answer is. It looks like a coordinate. And that's actually an infinite amount of answers, believe it or not. There are an infinite amount of decimals between 1 half and 3 halves. Fumble and fumble. That was a double fumble. They get a chance to get the first one in before he fumbled the next one. All right. Does this look familiar? What fumble? Okay, now we're just doing it. 9x squared. Now this is special. minus 6x, add 1, greater than 0. What can we expect? An in-betweener or go in an opposite directions answer? 3, 2, 1, go. Did you hear the rest of them? And if you don't know it, now you've fallen behind officially. All right? So this should be in opposite directions. But wait, this is special, and I actually did talk about a little bit of graphing last hour, but I don't want to talk about it anymore after this, but I might. What we need to understand is this is a special scenario that actually factors pretty fast. Perfect square, perfect square. Let's try this. 3x times 3x is 9x squared. What equals 1? 1 times 1, but a negative in the middle, minus 1, minus 1. Does that work? Is that the true factorization of this? Good foiler, say it. Good factors, 9x squared. Is this negative 3x and negative 3x? Does that equal this? Yes? Yes. And then negative 1 times negative 1 is what? 1. This is the factorization of that. But you know what the problem is? There really is only check one of these. This is a double solution. So 3x minus 1 equals 0. You get x equals add 1 divide by 3. So what happens on this one? Well, here's what really happens. Please pay attention. This is actually where the vertex is for the parabola. If you were thinking about graphing. And this parabola, which way does it go, up or down? If you graphed it, 3, 2, 1, go. Up. Come on, it's a positive 9. Positive a squared means. So if I were actually to graph this on a coordinate plane, the y-axis would be like right here. And this graph would actually graph like this. It'd look like this. Oh, all right. Thank you. It'd graph like this, which is up. Input, say it. Output. So that means when I plug in 0, I get what kind of output, positive or negative? What kind of answer is positive? Is that greater than 0, true or false? See, that's how a graph helps solve the equation. We're going to do this in chapter 2. This group is killing me. I can't pay attention when you guys aren't paying attention. Yes, these guys are driving me nuts. All right. And then negatives. I plug in a negative, I get a positive output. I plug in this number, I get a positive output. So the graph later in chapter 2, we're going to show you how a graph can solve these inequalities even faster. But we're going to go beyond x squareds. We're going to do x cubes, x to the fourths, x to the fifths, and solve those inequalities. So when I do a number line check, this would have been true, and this would have been true. Both sides. So it is an opposite direction one on this one. But this is what I would call a really special case. And this is weird. This is everything but 1/3. And I should make you aware of this. In Algebra 2 world, this would be this answer. X does not equal 1/3. Because a not equal sign means x equals everything else but that. You know, and I kind of should share that because you may run into this sometime in a different, like ACT, SAT or something. So that would be the set builder notation for this. Or sometimes they literally write out all real numbers except 1/3, but that's what a not equal to sign means. I really feel like I should cover that. Really should. Okay, and then we got another special case, and I did 6 and 7 last hour. I'm not doing 7 because 6 has something similar happen to it. But I will do one more after this. So there's this one and then one more. Don't analyze. I have a greater than, so it's going in opposite directions. Don't do that yet. Because what you got to do is get this isolated, just like you did with an absolute value, like the second example I did today. What should I do first? Get rid of the 6 or the -2? 3, 2, 1, go. It is 6. Okay, you can't divide by 2 right now because what most people do is don't divide the 6 by 2 as well. It's bad to do it anyway. You get rid of the -6 first, and it is minus because that minus is attached to this. And then I guess I get why the other teachers are ignoring this because then they're making them not memorize the flip thing. By the way, when I divide by a negative, what should happen? I just said it. Flip. And then this is where we should have a siren going off. Wait a minute. Well, let me do the thing, and then I'll show you what happened yesterday for this question. By the way, what's the square root of a negative? 3, 2, or no, what's the square root of negative 1 actually equal to? 3, 2, 1, go. No, I. It's the square root of negative 1, which turns into an I number. And what else did we do wrong? What should be in front of that I? Plus or minus. But wait a minute. That was my answer for yesterday. How in the heck do I analyze an I number with solving an inequality? And the answer to that is it's not good. If I were to think about this graphically, hopefully you remember I number solutions means the graph doesn't even cross the x-axis. So one of two things could happen. The graph for this, but it's kind of like an all jumbled up equation. Which graph am I looking at? Well, I guess we have to look at this x minus 1 squared one, less than or equal to negative 1 or equal to negative 1 to kind of really think about that. Or we do something different. That's why analyzing this graphically doesn't work. So really what we have to do is come back to this, go, wait a minute, we got an issue here. Let me go back to the original, which was this, and then think about that. What could this only be? What's the smallest number that could occur out of this after I do an evaluation? Here, I'll give you a hint. I plug in 1. What happens when I plug in 1? What do I get out of this? 3, 2, 1, go. 0. Is 0 less than negative 1, true or false? False. What else could happen? I plug in 2, 3, 4. I'm getting 4 minus 1 is 3. 3 squared is 9. Is 9 less than negative 1? True or false? False. What happens if I plug in negative 1? Well, negative 1 minus 1 is negative 2. But then I square it and I get what, everybody? 4. Is 4 less than negative 1? No. So what is the result of this? What could x equal? Nothing. Everything we plugged in did not work. That's a no solution. If, on the other hand, I went back, I got an I number, and then I go back and check, and everything I plug in does work, that'd be greater than a negative, then it'd be all real numbers. So this is tough, right? This is outside of the box. This is like, whoa, what do I do with an I number on a number line check? You can't, because it's a real number line, not an imaginary number line. So I go back to this and analyze this. Input output tells me there's nothing that could work at that spot right there. All right. It's the best spot to look at, too, the isolated spot. Okay. And then one more. This was what number or where at? Is this the bottom part? Really enjoy math. All right. That's like at towards the bottom, right? Right. Okay. So here's what we did with this one. X squared plus X and kept the minus 2. And I just I want to do one more example that does work nicely and give you peace of mind. Okay. First of all, what multiplies the negative 2 and adds to 1? 3, 2, 1, 0. 2 and negative 1. Right? So that means x plus 2, x minus 1. And then let's do the number line check. By the way, when it's greater than 0, can we expect in between or go in an opposite direction? 3, 2, 1, go. We can expect opposite directions. Expect. Don't do the x plus 2 equals 0. Subtract 2 from both sides. We got to get there. We got to get there. Got to have some confidence in your numeracy. And then you'll be a better CAT student. And then 0 in the middle. So I go back up to here, 0. 0 plus 0 minus 2. Negative 2 is not greater than 0. Just what I expected, a false in the middle, because I'm going to get a true here and a true here. And sometimes you could do that. You could really kind of trust these basic, like quadratic, greater than or less than a number. You can expect true, false, true, or false, true, false. If you really want to check, negative 3 squared is 9. 9 plus negative 3 again is 6. 6 minus 2 is 4. 4 greater than 0. True. All right. Done with that. So this is a bracket. I'm going to get the stamp in here. And then a bracket. Oh, the stamp is changing colors to red. And it's cherry with a splash of strawberry. Mmm. Delicious. I think so. But not online. Now YouTube knows. Union that with 1 to infinity and beyond.